Welcome back as we consider uh, looking again at common network protocols and of course the TCP/IP stack of protocols. We need to distinguish now further what we mean by network protocols, and we need to separate them from common LAN network protocols and common WAN network protocols. Those are really two different types of protocols, and there is a lot to this subject, so we're drilling down piece by piece into them and trying to get more ways and more perspective to understand them with, so that we can know how they really work and what they're really about. As mentioned earlier, we talked about network protocols as sets of rules and standards for data communications over the networks that we are working with. The network architecture, for example, such as Ethernet, can support multiple protocols and even multiple protocols concurrently as they run throughout the Ethernet network. Protocols are typically organized into suites or sets of compatible protocols. They're often referred to as protocol stacks, which is what I've called the TCP/IP protocol suite. I've called it the TCP/IP stack of protocols. A stack includes protocols for several different layers of the OSI model, and lower level protocols provide services for use by upper level protocols. The highest level protocols that we have communicate directly with the applications themselves, and communications protocols can be divided into two basic types: the connection-oriented type and the connection-less type. Connection-oriented protocols establish a connection first. This connection is often referred to as a virtual circuit, and this takes place before communication will begin. They also disconnect after the communication has finished. A connection-oriented protocol generally has a lower speed due to the bandwidth used to maintain the session once it's been established. A connectionless protocol does not establish a virtual circuit. Data is sent without establishing any kind of connection and may be sent at any time, so there's no synchronization as well. These protocols have low overhead and are generally used when speed is a high priority. Oftentimes email is sent by connectionless protocols. Another distinction between the protocols, of course, is their reliability. How reliable are they? Some protocols send acknowledgments, for example, for each transmitted packet. This makes a far more reliable connection, and it leaves less bandwidth, though, for actual data transmission. These are called reliable protocols. Protocols without these acknowledgments are known as unreliable, although this does not necessarily mean they are not dependable, because you can depend on them to a large degree. The common protocols used in Windows NT networks are TCP/IP, NetBEUI, IPX, and SPX. And this is currently true in the further developed new networks under Active Directory. Two vendor-specific protocols, AppleTalk and DLC, are also supported. There are characteristics with each one of these protocols. TCP/IP, for example, has a medium amount of overhead, whereas NetBEUI has a low amount of overhead. Are they routable? Sometimes they are and sometimes they aren't. For example, NetBEUI is not routable, neither is DLC. But TCP/IP, IPX, SPX, and AppleTalk are all routable. TCP is used in large networks and across the internet, and generally speaking in Unix compatible networks as well. TCP/IP as a protocol suite itself was developed primarily for use in Unix systems and Unix environments, and is a protocol used throughout the internet now. Windows NT's implementation, as well as Windows Server and all of the editions that we have out now, 2003, 2008, right on up to the present time. We now have Windows 7 running. TCP/IP has continued to show its usefulness and its strength in handling these wide variety of needs in a network. And it includes, of course, many of the protocols that we've already mentioned that are very reliable and very connection oriented, like TCP, and of course IP for addressing. The protocols in this suite are organized actually in the path according to the DoD reference model, the Department of Defense. It's a model that is similar to the OSI model, but it only uses 4 layers. The advantages of the TCP/IP protocol suite are the features provided by its wide array of protocols, its support for routing packets and so forth, and transport specific framing and segmentation of the packets, and its standardization throughout the internet and the Unix communities in the world. Its main disadvantage is that it requires more effort in administration compared to other protocols. TCP and UDP are the main protocols in the DoD host-to-host layer. This maps to the transport layer in the OSI model layer too. So you've got application, presentation, session, and then transport. And then we have network, data link, and physical. The TCP protocol is a connection-oriented, routable, reliable protocol with acknowledgments. It is dependable, but it has high overhead. So it establishes the connection, uses what we call the three-way handshake, where we have send packets and acknowledgement packets involved in establishing a connection before communication begins. The UDP is user data datagram protocol. UDP, user datagram protocol. It is connectionless. It's unreliable. It's a protocol with very, very low overhead. It can transfer data faster, but it does not send any acknowledgments or establish any kind of connection before it goes to work. NFS, is Network File System, is the TCP/IP suite's equivalent of file sharing. NFS, Network File System. This protocol operates at the process application layer of the DoD model. It's similar to the application layer of the OSI model. NFS support is not included with the earlier versions of Windows NT, but it is available separately, and it's also available in use now. We do have other more advanced improvements that have come along since the days of Windows NT. NFS provides access to entire file systems, or portions of them are removed machines, and makes them act as a subdirectory on the client machine. In fact, NTFS, New Technology File System, has evolved into Active Directory, which is our directory services, and this is, generally speaking, the way in which all files are now kept as objects on an Active Directory network in many Windows environments today. You also have IPX and SPX. IPX and SPX are protocols developed by Novell for use in network. Now, you don't see a lot of these, but you just need to be aware of them. They are based on protocols used in Xerox XNS network architecture. Part of it is what is known as IPX, the Inter-Network Packet Exchange, is a connectionless protocol that works at the network layer of the OSI model. And SPX, Sequenced Packet Exchange, is a connection-oriented protocol that works at the transport layer. Microsoft implementation of IPX and SPX for NT is called NWLink. IPX and SPX are commonly used in Windows NT networks that require connectivity with Novell networks. So you'll find that again, you won't find very many of these, but they are out there because we still have a lot of Windows NT legacy systems around, even though we have certainly seen improvements with 2003 and 2008 as we continue on with 2010 and Windows 7 and all of the improvements which have come of late in the last few years. Well, we're reviewing all of these older protocols and these older systems and architectures so that you are aware of them when you see them or run into them or hear about them. NetBEUI is a transport layer protocol. It's developed by Microsoft and IBM. It stands for NetBIOS Extended Use Interface. Network Basic Input-Output System is what NetBIOS stands for, and it was the Windows standard for workstation naming, communication, and file sharing. So NetBEUI is old. It's not routable, but it's fast. It has low overhead, which makes it a good choice for very small networks. However, like I said, it's non-routable, and networks that use NetBEUI can use bridges for traffic management, but cannot use routers. It won't work. Another disadvantage is its proprietary nature. NetBEUI is supported by few systems other than Windows. So again, it's an older protocol, but it's still around. It sometimes has to be used in certain networks. You may have to go turn NetBEUI over TCPIP in some of these networks, even to get your computers' names associated with your IP addresses and so forth. AppleTalk is Apple's suite of protocols for networking, file sharing, printer sharing between Macintosh computers. AppleTalk can function on Ethernet, Token Ring, or what is known as local talk networks. Windows NT Workstation and Server include an implementation of AppleTalk. Microsoft servers for Macintosh included with Windows NT Server provides additional support for Macintosh computers. Then there is Data Link Control, DLC. It's a transport protocol developed by IBM for SNA, that's Systems Network Architecture. I mentioned that earlier in one of the lectures, SNA. This is a protocol suite that's used for network communications with mainframe computers. Particular versions of DLC are called SDLC for Synchronous Data Link Control and HDLC for High-Level Data Link Control. Along with its uses in mainframe communications, DLC is a protocol used by many network-aware printers, such as Hewlett-Packard's Jet Direct interface. Windows NT includes support for DLC that can be installed to use these printers as NT printers. Now we have common WAN architectures, and we need to talk about those. Those are typically used cable that's wired specifically for the network in a single location, the LAN type of network. The WAN and the MANs, though, usually use public or leased lines provided by a third-party carrier. WAN services can be provided by dedicated lines or switch networks called shared. They're shared networks. Public networks are characterized by their switching methods, the methods in which data is routed between different points in the network. There are three switching methods currently used. One called circuit switching, then there's message switching, and there is packet switching. Now, packet switching is a more efficient connection-less communication method. The packets are sent individually and can follow different routes to their destination. Some packet switching systems can use virtual circuits for a logical connection, but don't use a dedicated physical connection. More often, you're going to find that you have packet switching networks. Circuit switching is a connection-oriented method of communication, so it is a dedicated circuit to the connection, and a connection must be specifically established when needed and disconnected when not needed. Message switching is a connectionless method of communication. Individual message units are sent across the network with routing information without establishing any kind of dedicated circuit. WAN connections typically require different hardware than your LAN connections. Typical WAN equipment includes specialized routers, what is known as CSU/DSUs, which stand for Channel Service Unit, Digital Service Unit, and multiplexers, which combine multiple signals such as voice and data for transmission on a single WAN connection. A number of WAN technologies and public networks are available. FDDI, explained earlier in this chapter, can also be used for wide area networks. The common WAN technologies are described in detail too in the reading material. We may not go through all of them. We have the PSTN, the Public Service Telephone Network. We have DDS and switched 56. And DDS is Digital Data Service. Switch 56 is an alternative to DDS that provides the same type of connection but in a circuit switched format. You also have something called ISDN, the Integrated Services Digital Network. It was originally developed as a digital alternative to the standard PSTN telephone system for voice communication. It was introduced in 1984, but is now only being widely implemented in the United States. There are two types of packages: the basic rate interface and the primary rate interface. There's also T1 and through T4 lines. The T1 line is a high-speed, dedicated point-to-point leased line that includes 24 separate 64 kilobyte channels for voice or data. Other lines of this type, called T-carrier lines, support large numbers of channels. Like T4 has over 4,000 channels, and it can have a total bandwidth of nearly 275,000 megabits per second. That is pretty fast for a hardwired line. Then you have X.25. It's a protocol developed in the 1970s for packet switching, allowing customers to share access to a PDN, a public data network. These networks, such as SprintNet and TimNet, were the most practical way to connect large companies at the time and are still used by some companies even today. That's X.25. Finally, you have three very big ones that you hear about quite often, and that's frame relay. Frame relay is a protocol used with leased lines to support speeds up to 1.544 megabits per second. Frame relay uses packet switching over a phone company's network. Frame relay connections use a virtual circuit called a PVC, a private virtual circuit, to establish the connections with. Once they are established,